All right, let's talk about elimination bimolecular, or E2. So elimination and two molecules. This is a counterpart to elimination unimolecular, but that happens in two steps, and this happens in one step. So that's why this is one of those that we're going to talk about. So let's look at this mechanism. Now we'll pick a good leaving group, and we'll have a hydrogen up here. And one of the things that we'll need is a good base to rip off this hydrogen. So let's go with hydroxide because that's a pretty good base. So we've got OH. Now this happens in kind of three steps. And so we've got our negative charge right up here. It's going to abstract this hydrogen, which will then cause those electrons to move into the carbon bond here. And then to maintain the octet, we'll have this leaving group, the bromide, leave. And we'll end up with three products. Water. There's a new bond right here. I'm emphasizing that. Plus our cyclohexene. Plus our leaving group, bromide. So this is how the elimination mechanism works. Let's draw a few more like that just to show some of the other possibilities. Let's stick with, well, we'll draw the base on in a second. So we've got a carbon-carbon bond here, which is going to be bound to this nitrogen, which is a quaternary nitrogen, so it's got a positive charge on it. That should make it a very good leaving group. And we just have the rest of the molecule here, but I'm going to specifically draw in this hydrogen. Of course, there's other hydrogens on here, but sometimes I'll omit those just for clarity, but I better write it on here. I'll write it like this so that way we'll emphasize that this bond is going to be destroyed. So we've got our negative charge on the hydroxide. We'll use that as a base as well this time. That will come take our hydrogen, and the electrons from the hydrogen bond will go here. And then we need our leaving group. It's not going to be this carbon stuff right there. It's going to be that nitrogen right there. Come up there. And we're going to make, again, water, because we used hydroxide as our base. And we'll make a new double bond right here. Still have those two hydrogens on it. Let's see here. The rest of the carbon stuff there, plus our trimethylamine, which now has no charge on it because we've had this negative charge kind of work its way up to where the nitrogen is. So, as you'll notice, this elimination causes a double bond in these, but we can also have it form a triple bond. We just have to start off with something that has a double bond in it already. Then we could go up one more. So let's do that. We like to use bromines as a leaving group. They're a pretty good leaving group here. So here we have double bond right here. And let's see here, this would be 1-bromoethene. This would be the first carbon right there because the priority would be from the bromine. And we'll pick a different base here. We'll pick ammonia's counterpart. molecule a little bit more of the blue stuff. So we've got a fairly reactive base. Should be pretty strong. It's going to attack this hydrogen here. It's going to attack the hydrogen opposite on the opposite side. So, and then those electrons will end up in the carbon-carbon bond, and we pick the leaving group. That's going to be the bromine. And we're going to make 3 products again. It's 3 steps here. We make ammonia. We make acetylene. And we make bromide, which was our leaving group. So this is an elimination bimolecular, or E2. Elimination, 2 molecules coming together. Here's the first one molecule, here's the other one. There's also elimination unimolecular, or E1, but it has several different steps in the mechanism, which are made up of some of the other little pieces that we're talking about in this series. We'll get to the other kinds of reactions later.